Use properties of logarithms to expand each logarithmic expression as much as possible, and where possible, evaluate the logarithm without a calculator. Now to do parts A and B, I'm noticing that inside of the logarithm, I have products. Here I have 7 times 5, and then here I have 10 times x. If I want to expand a logarithm that involves products, I can use this formula right here. As long as I have the common base, I can rewrite this expression as the sum of the product here. So here for part A, I have log base 4 of 7 times 5. So I can rewrite this as log base 4 of 7 and sum it with log base 4 of 5. Now I can try to simplify these a bit further. So if I use the regular definition of a logarithm and recall that the definition, all I have to do is get 4 and raise it to some quantity, and that quantity has to produce this 7. But this quantity is not going to be trivial, so here I would need a calculator, so I'm going to leave it as is. And then the same thing is going to happen with this part here, because it's not too obvious what I need to raise base 4 in order to get a result of 5. So I would be done with this statement as is, and I can do the next problem. So if I want to expand log 10x, I want to remind you that whenever the base is not specified, we're under the assumption that this is base 10. So base 10 is not usually identified for you, so I'm not going to emphasize that either. Now log 10x, I'm going to rewrite it as log 10 plus log x. Here on the left, log base 10 of 10 would be 10 raised to some quantity x, and that has to give me 10. That's the definition of this logarithm. And I know that if I let x equal to 1, that is going to solve this expression here. I'm going to simplify this expression. So log base 10, that's just 1, so I can rewrite this as 1 plus log x. For the two other problems here, I am using division now. And whenever I have a ratio inside of my logarithm, I can attempt to use this formula here. So the ratio, as long as I have the same base, I can rewrite it as the difference of the ratios, the numerator subtracting the denominator. Here for example C, I have log base 7 of 19 over x, so I can rewrite this as log base 7 of 19, and then we're going to subtract log base 7 of x. If I take a look at this part, I need to find the power such that if I have base 7, if I raise it to x, I should be getting a 19, but that's not obvious, so I can't do that without a calculator. So at this point, I'm going to leave my expression as log base 7 of 19 subtracting log base 7 of x. Now I'm going to do part D, applying the same recipe, and notice that I don't have a base specified, so I'm working with base 10. I'm going to get log of x, and we're going to subtract log of 2. And very similar, I'm not going to be able to simplify this any further, so I'm going to keep it as log x minus log 2.